Okay, welcome. Day 2 of the Keith Parsons project. I cracked that one on the first conference and it fell just as flat, but I will try and keep my sense of humor under wraps most of the morning. So I'm going to talk today about 5G, enterprise networking, and I'm going to rattle through this stuff fairly swiftly. But it's something that I think is important and is going to be important, and the people we work with in the industry and our customers are going to start asking us about the 5G story and what we're doing with it. Because it's good. So let me just run through. Why should we care? It's a very imaginative architecture. And of course, 5G, I'm talking about what comes after 4G, which came after 3G and 2G. And we think of as cellular networks. 5G is way, way bigger than that. And that's what I'm going to talk about. So it's an imaginative new architecture. It's got some very, very deep pockets behind it. They are going to give this a very strong shot. And it's a cliche, but it's a compelling story. It's convincing. And if it takes off, everyone who sells into and services enterprise networking customers and who run those networks will be affected by it. I don't want to get apocalyptic, but we should be aware of this coming along and start thinking about how it's going to change the world we live in. Okay, what's driving it? Well, you can look at two things. You can look at carrots and sticks. I tend to be a pessimist, so I'm looking at the negative drivers, if you like, and all the lines on this slide are about 4 years worth of trends. I've got, I think, in order from the top right down, US subscribers going up very slightly, US cell phone ARPU, average revenues, sagging, so every subscriber's paying a little less every month. And then on the left, I've got chip providers and wireless equipment provider revenues. Again, going down slowly. And of course, this was fairly well predicted a few years ago because we know that 2G had that sort of peak and trough, and then 3G had its peak and fell off, and 4G is still going up, of course, but at some stage, the new equipment and all that, new sales will start to sag, and it looks as though we're getting there. So the industry, the cellular-based industry, had to do something in order to keep selling stuff after 4G. And there was some pretty neat technology coming along. There's some really, really neat technology. So you can look at it either way. Either they're able to do a lot more things, or they need to think of a few more things in order to keep driving their revenues and profits. So the 5G story, I've just put up a few of the things that I think are important here in terms of powerful ideas. There's this drive to manage service, paying per month, things coming out of the cloud. There's this image of the cellular network as being reliable, high quality, secure. I think all those things resonate with customers. We can all look at various aspects of them and say, well, that's not quite right, and so on, but they resonate with customers, and that's what matters. So along comes 5G, and here's this sort of spiderweb chart has started to get a little popular, and it goes through all the different dimensions in which 5G is going to be better than 4G and super, and I'm not going to go through all of them here, but you can read through as you go. But 5G technologies, for me, can be broken down this way. Now, different people will do it different ways. There's a heck of a lot of stuff there. I'm going to do it this way. I think it's fairly conventional. Not everyone would do it the same way. So new radio and spectrum, small cells, licensed, unlicensed, low data rate options, network slicing, the MEC. The MEC is going to come into this, and software control everything. All good subjects. So the first one's the radio. 5G NR. New radio. It's not very poetic, is it? Not very poetic. I wanted them to do something with scary, sporty, baby, ginger, posh. I think they should start calling it 5SG, Spice Girls. Now you could do something with that, right? They need a little bit of work. But I just bet someone I could get the Spice Girls into a talk about 5G. Have to work on it a bit. The radio. The radio's got some really neat technology in. Look at the top left, we've got massive beamforming, 64 by 64. Beamforming, in the same way we do MIMO today, but much, much bigger scale. We're going to millimeter waves. Up at the top right there, I always have to figure this thing out for myself. So 60 gig is about 5 millimeters for a wavelength. And the bands generally are in the 28, 38, and 64 gig range for the extra stuff that you can do there. Pretty interesting things that you can do up there. They've got direct connections in this thing, so we can start connecting cars directly to each other under the 5G radio. And then there's some cooperative, multi-point kind of stuff where you can be connected to multiple base stations at once. There's a whole lot of stuff in here at the radio level. And pretty interesting technology, I think. As we go outside, we get to small cells. 5G is going to be an awful lot about small cells. And if you go back 10 years, the Femtocell Forum started. They've now turned into the Small Cell Forum, very much behind this. So a small cell in the 5G world outdoors is like a micro base station, covers a pretty small area in the same way we do in Wi-Fi. So you can get a lot of frequency reuse, which means you can get high network capacity. And some of the interesting things that you'll see going on in 5G at the moment, there's a big sort of push against regulation because they need to get a lot more cell sites out there to put these radios on. And all the regulations that various cities, counties, and so on, jurisdictions have, take a while for them to get through. So that's a big focus right now. FCC is looking at it as well. But once they've done that, they'll still need to figure out how to get all these radios out there, how to do it economically, how to install them, how to manage them. But it seems quite clear that small cells, in that sense, are a part of 5G. When we start moving indoors or even outdoors, the other angle of small cells, at least for me, is licensed and unlicensed. Because you can start to put this radio unit up that has maybe 2 radios in it. And those radios can be in different bands. In particular, one of them can be at the 5 gigahertz band, which we know and love, of course. But it's an unlicensed band. It's open to everyone. And the network operators have their eyes on this because it's very good for adding capacity. And we have a whole range of protocols we can use up there. I've listed a few of them: LWA, LWIP, LAA. There are various combinations of using a licensed link to, let's call it a cell phone, a device, and then adding capacity by using a 5G link in parallel. And that 5G link could be straight Wi-Fi, it could be LTE type waveform in LAA, It could be uplink only, it could be uplink and downlink, and then finally you get rid of that licensed anchor connection on the right, and you've got multifier, which is LTE waveforms or 5G waveforms. 5G as in 5th generation, in the 5 gigahertz band, unlicensed band. And all those are coming along. We'll see which ones end up being important and which ones aren't. But I'm sure the whole principle will be important as we go. The reason to do that, of course, is that broader channels means more bandwidth and higher data rates. And 5G will continue the 4G tradition of being able to bond together disparate channels in the same way we do 20, 40, 80, 160, but these can be non-contiguous channels, and they can be licensed, unlicensed. A lot of options there. So these are building blocks. I'm going through the technology at the moment. At the other end of the scale, we're looking at low rates. And you've all heard of IoT. IoT means many, many things to different people, and that's okay. But for most of us, it means low data rates, going long distances to battery-powered, very low power sensor controller devices at the other end. And we did our thing in Wi-Fi for this with 802.11ah. And the cellular equivalent is Cat-M1 and NB-IoT. The interesting things here is that these are part of the cellular network. You can hang them on the same towers and everything. They bring down the bit rate, they extend the range, and they give you good battery life at the other end. All good things for IoT. Talk a little about network slicing. So this is a fascinating concept. Everything is going to software, as I'll put on the next slide. If you want to start running QoS through big networks that are software controlled, 5G says the way to do it is to start reserving resources through each function. I won't call it a box because it's going to be software, that a connection runs through. And the idea here is that we can start to reserve these resources in order to make synthetic networks within the network. So we could have one for high bandwidth, maybe with high latency, if you want to send one-way video, broadcast video across the network. We could have one with low latency, but that usually would go with low bandwidth. You could have one for Corporation A, because it might decide it wanted particular characteristics through the network. So especially at this stage in our development for 5G, which is that everything's on PowerPoint, and there's a bit that's got off it, but not a heck of a lot, you can do anything with this. It's really easy to write a slide. I don't want to be too acerbic, although it's early in the morning and that's the tendency. But this is a very powerful idea. I think there is quite a question about how easy it turns out to be to put into practice. But you can see that this is a way that will allow network operators that today have just one homogeneous kind of network with one homogeneous kind of connection to start offering different services. And then they can start exploring different price points and that kind of thing. Could be very interesting. Quite anti-net neutrality, incidentally, which is one reason I think that they don't like the net neutrality concept. And of course, that goes hand in hand with software control. So it's a commonplace that software is eating the world. Some of the carriers have already put quite an effort into moving into software. So they're trying to get away from that picture on the left where you buy a box from a vendor and it's got its own management interface and you set it up and then you connect some cables to the next door box, and that's how you build a network. There are various concepts here, and you could take it different levels. But if you can think of software functionality, maybe they're containers, floating in a sort of a sea of operating system, and every time you want to make a connection, you stitch together these things, you chain them, and build your connection that way. Very interesting, powerful concept. And that big red sort of box at the top there is sometimes called orchestration to orchestrate it. If you look at the bottom diagram, that sort of goes everywhere. So to get to the cell site, they can start to pull functionality back from that radio that used to sit on the cell tower and stick it in this baseband unit, and then connect over fiber, generally dark fiber, to get to the radio head on the tower. And now you can do a lot of work in that baseband unit to change configurations, to switch things around between cell sites, to load balance, all kinds of clever stuff. And you've got this concept of front haul and back haul and cross haul and lots of other things. Final thing on here to do with software is this mech. So I'm going to start introducing the mech. I'll talk about it a bit more later. So the mech is a box where you can push functionality down closer to the user. That's one way of looking at it. And I wanted to introduce that on this slide, the mech. I'll come back to it. All right, that's a quick run-through technology for 5G. I've missed a lot out, but I think I've hit the important things, at least things I think are important. Now about markets. Where does it take us? Where does it take the people who drive it? And this is the IMT diagram. I find these things make my eyes water, and so I'm not going to spend much time on it. But go down the left-hand side and just look at these markets which 5G opens up. We've got the consumer internet, if you like, to a cell phone. That's what I call a current market. They've got funny acronyms for these things that I've put up. I'm not going to dignify them by talking specifically or indeed mentioning their names. So we have the current market, which is pretty much internet to cell phones. And then we have a bunch of new markets. So we have fixed wireless broadband access. We have some IoT, we have some smart city and factory networks, and then enterprise networks. And you can see that with all those technologies I went through earlier, you can do a lot of new things, and you can go into a lot of new markets. So the first one, and perhaps the least interesting, is the consumer market, because as I pointed out earlier, I don't think, well, we didn't make enough babies 10 years ago, or whatever age kids get cell phones these days, maybe 7. So the population ain't growing much, and each of them isn't paying much more per month. Therefore, there's not a heck of a lot more revenue out of that little bit. But on the other side, the demand is still growing like fury, unfortunately. Well, unfortunately in that sense. And I wanted to put up a VNI slide here because I think all of us in this industry owe a big debt to Cisco for doing that, coming up with these figures, whether we believe them or not. But you've got to have figures, or you can't point to things. It looks like video, which is obviously the biggest driver of bandwidth requirement, is going to continue growing and is just going to keep going. And that means the people who build networks to support that traffic have to keep making those networks faster. So it's a pretty important part of the 5G market, and they have to keep up with it. Fixed wireless access is new, but not completely new. It's probably the third wave that we've seen of fixed wireless access. I've seen it in the rural setting, where you're trying to get to scattered dwellings, where maybe it's too expensive to put the fiber out there. And I've seen it in the urban settings. You can look at the Facebook terragraph. pictures where they want to string it along the lampposts, hop to hop to hop, and then it ends up with a box on the dwelling, on the house. Sometimes it's a box on the outside, and generally it's going to push Wi-Fi into the house. So this is like a replacement for your cable internet service, your DSL. It's wireless. IoT. So IoT is a funny business at the moment. Some of it is working, some of it's not working yet. Cars are definitely working. Factories are definitely working, if you want to call that IoT. There are some interesting things happening in cities. It's very hit or miss, in my opinion, where the money is right now and where it isn't. But there's certainly a lot of promise all across the board. And the mobile operators have a good position here because they can cover the wide area. They can cover 10 kilometers with this sort of technology from the tower, and that's a good radius. That means you can get out there, you can put out meter reading networks, you can do citywide networks. And I think one of the big questions going for the next few years is going to be, does this sort of IoT become a cellular operator market, or is it in some way going to be a private market? You've got LoRa technology that can do a similar sort of thing on the private side. Then you've got the independents like the Sigfox Ingenues. It's going to be interesting to see how this all plays out. We've sort of blown our chance on it with Wi-Fi because extended range AH is not moving as fast as it should have moved, in my opinion. Although there's stuff coming along in AX that will help us there for the building, small campus type of area. All right, I'll come back to this enterprise idea because that's what I started off to talk about, 5G in the enterprise. And I'm sort of talking about enterprise in the broad sense. So what does it mean to our kind of day-to-day work? And I've got a few slides that go through my ideas about that. I'm frequently wrong, so please look at this as a set of ideas to test your ideas against. If you go away from this with a few thoughts in your mind, and when you see things in the press over the next couple of years, you say, aha, I recognize where that's coming from, then I'd be very happy. So the MEC. The MEC has become a vehicle for a whole lot of hopes and ambitions in the last couple of years. It started as, I think, as mobile edge computing, and now it's been taken over by ETSI, multi-access edge computing. Actually, the chair of the ETSI group is from my company. There's all kinds of angles. Oh, and incidentally, I don't think I said at the beginning, but please don't go away assuming that this is a company view. It's a very personal view. Our company is very large. There are many different views. This is my little corner looking from my perspective. So at its simplest, this MEC is a box that's out near the radio that you stick a lot of software on. And one thing that this is good for is getting the application or the service, if you like, closer to the device, which cuts down the latency a lot, or should do, and reduces the traffic. So the traffic that sort of goes on that northbound thing, which could be over a lot of internet to the cloud, and the cloud could be AWS, where you're paying by the bit that you're receiving and transmitting. You don't want to push too much traffic out on that. So if you've got, let's say, video traffic, then it'd be nice to take that just behind the cell tower, process it, decide what's useful and what isn't, and only send the useful stuff up into the cloud. You can say the same for machine learning. We have two machine learning architectures. They both use a similar kind of thing. So there's a box there that compresses data in my sense, and then just sends what's needed up to the cloud behind it. Data reduction, sort of interesting. Maybe some privacy angles to this because you're not exposing data over the wide area, although of course you shouldn't really be doing that anyway. So the sort of things that are basic to the mech are how does the device find it? That's discovery, registration, how does it figure out what services are on the mech versus in the cloud, the general cloud, all that sort of thing, all quite tricky. But that's what the group is working on there. But the mech can do more. At least on a PowerPoint slide, it can do a heck of a lot more. And one of the things it can do is routing. Routing. Sending bits around. And here I've got a picture where it sends the bits into your private network, or into the cloud, or into the 5G core network. And that's quite a useful thing, obviously, if you start to put this in an enterprise network. Because now you can be inside the firewall, you can go direct to your apps, you can keep stuff pretty private if you want to, put your own security on it. Gets you into private LTE type networking. And here we are with private LTE networking. So people are building these networks in a box. We think of the 4G, 5G core network as very big, very expensive, and very complex. And it is. It is. But people are beginning to build things in software. They're beginning to scale them down. And we can see the day where you would be able to buy a network in the box that sort of functionally has all the bits that you'd see in, let's say, a Verizon wireless network core, but at a price point and a scale that we can figure out in an enterprise network. And that opens the door to running completely private LTE type networks, which again, people are starting to do, particularly in the LTE, in the IoT world, I think. That sort of automation machine based. So there's a network in a box. And not surprisingly, once you've got a mech, you can say all this stuff's just software, and you throw it on the mech. Right, the last little bit's about small cells. And I talked about small cells as a technology. Small cells, when it comes to enterprise, again, they've been around a long time. Probably back to, what, 98, 99, 2000, jet cell, radio frame, those guys. Starting to do indoor GSM Office, we called it. So the first thing you need for that is a little radio unit that sends out the right wireless signal on the wireless side and has an Ethernet connection on the back side and can be core-connected. That's pretty much a femtocell, what I would call a femtocell anyway. And you can start going around the building and sticking them on the walls and getting yourself indoor cellular coverage. You start to get a whole bunch of them, and it's worth putting a controller behind it or doing some sort of distributed management across it, because you probably want the handovers between these units to be within the network and not to be anchored in the core network for scalability reasons and some others. And people are building this kind of network today. And there's actually quite a lot of commonality between that and what we do in Wi-Fi. Generally, the LTE 5G people will say that I think you need maybe one of those radios, one of those small cells for 4 Wi-Fi radios, something like that. It depends what you expect in the way of coverage and capacity, of course. Same things apply as they do in Wi-Fi. So we can go to that controller base, and of course the controller in this case could be a small cell controller, that's what the Small Cell Forum calls it, would be a surrogate and would be managed from the core 5G network behind it. And then over on the right, I've got a little orange. So I've tried to use orange for unlicensed and blue for licensed here. I'm not sure why, I just thought that was the way to do things this time. So Princess Kate, I guess Duchess Kate, does her own makeup, did her own makeup for her wedding. If you didn't know that, you're not reading the right magazines. I do my own pictures for my slides. You'll have to judge which one has the better results. But I think I exposed the bone structure rather better. Yeah. I'd better get off that one. Okay. Where was I? Yeah, so licensed and unlicensed. Yeah, licensed and unlicensed. And this unlicensed radio can be a Wi-Fi radio. Can be a Wi-Fi radio. So now we've got people pushing these small cells in to the enterprise, and they got Wi-Fi radios in them and cellular radios, and they can all be managed by this network in a box, and they're under the 5G. So now we're beginning to build that picture of what an enterprise network might look like in a 5G world, which is what I've been getting at. And I've got three angles of it here, which I've covered. There's the small cells angle. So you can bring in these multi-radio boxes, stick them on the wall. They do your cellular coverage. They do Wi-Fi and or other unlicensed. You've got the slicing. So now I can put the slices between my corporate locations, maybe, or from my corporate location to the cloud, and I can have different QoS available. So I can segregate my traffic, assuming I know how to do that. And stick it up different slices. And then I've got this MEC, which sort of pushes functionality out of the cloud and out of the 5G core down into the enterprise. And once I've got that box in the enterprise, I can stick a whole load of software on it, including the small cell controller and so on. So this is what we might start to see in enterprise networking. I think you'll agree it's fairly different from what we do today. I hope you'll also agree that based on the last 15 minutes or so that I've been talking, it's quite credible. It's a very credible story. The one thing that I'm a little concerned about is that right now 5G is really owned by the mobile operators. Really owned by the mobile operators. People are beginning to put up charts and say, one of the things we'll see with 5G is we'll see a whole swathe of new types of operator. And I think that would be really interesting, and I think that's probably a requirement for this to really take off. I think if it remains something that only the mobile operators can sort of do, then it'll find a harder sell. But we'll see. So I just got a few more words to say about this, and then we'll wrap up. There's a whole bunch of things that you can come out with in terms of advantages for doing it this way. And I hope it's fairly clear. I'm not going to go through all the bullets on that, but it fits in with a lot of the things that enterprise networking is already moving towards. We've certainly got a pretty decent business in providing equipment to service providers that do a managed service now. So they just go out to the customer, they install, they manage out of their NOC, they produce a bill every month. And the customer doesn't have to worry about CapEx, OpEx, all that kind of thing. Certainly works for certain types of customers. There's a whole lot of challenges, and I'm not going to go into those. My job today is not to tell you whether this will work or whether it will not work. It's just to get you thinking about the ideas, I think. So here are a few things that we could look at going forward. Enterprises want to get out of the network running game. I think there's a general trend in that direction. 5G operators have scale, they can do things cheaper. Good argument on its face, I think. Just have to see when you get the bids what the prices really are. Monthly OpEx pricing, good thing, yeah. Moving to the cloud, less on-prem. Again, that's something everyone will nod along to at the moment. Talent scarcity. Network operators can take things off your hands. You won't have the recruiting headaches. I think that's a reasonable argument in a lot of cases. A lot of counter-arguments, obviously. I'm not going to go too deep there. I do want to mention the go-to-market. So one of the interesting things that we'll see, assuming the operators push hard down this track, and I think they will, for the reasons I'd said earlier, is they'll have to figure out how to sell and deliver into enterprise. And they'll come up against some fairly obvious challenges there. I believe, anyway, that enterprise sales are more complex generally than sticking something in a phone shop on the high street. It's high touch, so you need people who can go in and do those sales and can talk about the features, the complex features, and then can make sure that these things are going to work. That's generally what we have in the high-tech sales force in enterprise networking today, I think. Surveys and install. Well, I've talked to a few of the mobile operators about how they'd get small cells into enterprise, and it is just extraordinary how many steps they have to go through right now. They really have very organized processes, and those processes are probably too heavyweight and expensive to do installations on the scale that we're talking about here. Help desk and troubleshooting. Again, people in enterprise networks expect to be able to get help when things aren't working. And one could argue that that's something that the mobile operators have not excelled at to date. So there's all these things that will need to come in, and my guess is that the people who do those things today in a 5G world would end up doing them, but in support of the different architecture. But we'll find out, maybe. So here's a few thoughts to leave you with. How will this play out? In 5 years' time, might be longer than that. So the first thing is it's going to take a heck of a long time. This stuff moves slowly. But it's quite possible that in 5 years, we will all run everything on the cellular network. Everything will run on smartphones, tablets, PCs will be network connected. In a lot of the world, they already are in huge quantities, much more than we have in the States. All apps are in the cloud or in the Mac. And all you need is a subscription. You just get on and you go, and it works here. It works when you're driving to the airport. It works in Enterprise A. It works in Enterprise B. So that's sort of a SP utopia. And the first time I came across this was probably about 1998. It comes back every few years. It's going to come back again. We'll see how far it gets. In such a world, we'll all be working for the mobile operators. That's my contention. In some way. But we'll probably end up doing most of what we do today. Not a bad idea. If it fails, if this whole idea never comes to anything because the mobile operators can't change enough, or it's too difficult, or they find there are other better markets to go after, or they run out of money, any one of a number of reasons, then I would argue that we still need to know a bit about it because it'll take a while before people realize that this ain't going anywhere. I would quote you WiMAX, maybe. WiMAX had a lot of momentum, even though it didn't get a lot of traction. And that was something that most of the mobile operators really weren't behind. Because if you had a 2G network, then you were going to modify it and make it 3G. You weren't going to toss it out and make it WiMAX. At least that's my argument there. So, The probable middle ground is that we'll find that this architecture works in a lot of cases, or a few cases, but it works in some cases, and it doesn't work in other cases. In that case, we'll end up with a hybrid. But we'll still have had, I think, quite a bit of fun looking at new stuff. And I'm pretty sure we will be able to put shoes on the kids' feet come February 2023. Thanks very much.